Today on the bench, I have an Ingersoll-Rand 285B 1-inch air impact. Now, I can't show it to you in its entirety because right now it's in pieces. Because I thought that the only thing I was going to have to do was replace the throttle handle on it. This one is cracked all the way through here, and you can see on the underside, it looks like somebody tried to use a JB weld or some epoxy to repair it, but of course that's not going to hold. So my customer asked me to simply replace the handle, and when I called my part supplier, which is a company called Power Tool Repair in Ohio, I talked to the parts manager there, and he said, tell you what, he said, instead of selling you a new handle and then having to remove all the fittings from here and replace on there, he goes, I'll sell you a used one that's been fully assembled. I said, that sounds great. So he sent that to us for the same price as the new handle, without all the pieces and stuff, and none of the labor involved in having to do that. So when I got it, I thought it'd be a simple matter of just popping the old one off and putting the new one on, and it was. It's just 4 bolts, take them off the back, slap the new one on. So I wasn't going to shoot a video on it because I really didn't think it was that interesting. But as I was looking over the rest of this unit per my customer's request and giving it the once over, I noticed that it's very interesting inside, and I figured I'd at least show you what the inside of one of these things looks like and how it functions, and compare that to the 3/4 and 1/2 inch ones that we're more familiar with seeing on this channel, because the mechanism is rather different and it's pretty cool. The first thing I wanted to show you is the rotor housing and the rotor itself. It's very similar to the 1/2 inch units, but of course everything's just much, much larger. And the rotor assembly fits inside the housing here, pops out the back where it exposes the bearing. And the rotor itself has vanes or blades in it, just like its smaller counterparts, but of course this rotor is much, much larger, and it rests in this plate with a bearing in the back. And I wanted to look at this, obviously, because I have to make sure everything's in good working condition. I want to check the condition of everything, and this seems like it's really good. It's surprising how good the internals of this unit are. I figured it was going to be pretty used and abused based on where it came from before it was owned by my current customer, and I'm very happily surprised to see that is in excellent condition. If you clean this stuff up, and it actually looks like it's new, it doesn't look like it's been used hardly at all. You can see how good the surfaces there are of the rotor. The blades don't seem worn down hardly at all. They still move freely in their slots. So what I'll do is I'll just take these out, drop some new lubrication in them, and reassemble it all. I want to clean out the old lube too, so I'm just going to wipe this down. Need some grease in that bearing, so I'll just repack that. When you lubricate the rotor and the vanes, just a couple of drops of oil in each slot is all that needs, because you should be oiling this tool on a regular basis anyway, so when you're done with a couple of drops in the air inlet, pull the trigger, and it should keep this whole assembly well lubricated. And after you're tapping on something, always make sure parts still move freely like they should. It's entirely possible that you could bend something or jam something. Okay, because I'm tightening a piece against another piece with a gasket in between, I have to make sure that when I do that, I tighten these progressively and sequentially so that I evenly compress that gasket. So I start with I start with my power driver at the lowest setting. Once I've made sure that all those bolts are going to go back in their holes properly. And then I increase the torque. And I go in a cross pattern to make sure that I'm applying even pressure against that gasket. And that's a small driver, and these are good sized bolts, so I'm just going through it manually to make sure that everything's tight. Now that the rotor assembly and throttle handle are back together again, I can put the body sleeve on it. Now this is the hammer assembly, and it's pretty cool, so I wanted to show you how it's all put together. There's only a few pieces to it. There's this outer plate, front plate. There's the hammer. And bushing. And then the housing, and that's it. And I don't know if this is actually a true bushing or not, because it does provide a function against the hammer where that slot in the top there engages the hammer. And then the anvil is just this big old anvil, and when this gets inserted in there, the dogs on the anvil here are what engage the hammer, and the hammer can pivot because it has that large pin. That hammer can pivot depending on which direction the anvil is moving in to move one side of the hammer out of the way while the other side of the anvil impacts it. So it's a clever little design. And this is a lot of material here because it's such a big, beefy unit. So everything in here is going to get some grease. It's kind of hard to screw this up because everything just nests back in place. And you can see how that hammer is going to pivot in there and engage one or the other of the dogs on the anvil based on the direction it's traveling. And this plate just rests back in there, and there's a notch that goes over this pin. And it rests back in like that. So I'm just going to lube it up and then put it back together for real. This bearing just sits right in there, so I'm going to pack that. I believe these bearings are shielded. When I was disassembling this unit, I noticed that there were some flat pieces of debris laying around inside the housing. They weren't affecting the function at all, but I suspected that they were maybe a deteriorated shield around this bearing. The shield is meant to keep dust out of it, but because this is all sealed up in a housing, nothing from the outside is going to get in. So I'm just going to re-lubricate it, and it should be fine. I've seen plenty of impact units that should have shielded bearings where the shields were not on the bearings, or someone used an unshielded bearing for it, and they function fine. It's just another maintenance item for you to keep in mind that, you know, like any machine, these things should be disassembled, cleaned, re-lubricated, and inspected on a regular basis. Most guys don't do it though, but part of that maintenance is going to be making sure your bearings are lubricated properly, especially if you're using unshielded ones. As I'm cleaning out the hammer housing, I've noticed that there appears to be, see if I can zoom in on it for you here. A crack. See it right there? It doesn't look like it goes through because there is some excessive wear on the outside. It looks like as someone was using it, so they were shoving it into something and it was being worn and compressed right there. So that is why that crack is there, I believe. If it doesn't go through, I don't think it's really going to affect much, if anything at all. It's not as if the front portion of this unit requires air pressure to work. I mean, it's not like you know, the anvil isn't sealed going through its opening. So if a crack were to form there, I still think you'd get full power. You just have the integrity of the housing compromised. So I'm going to note that for my customer, but I don't think it's going to be a big deal for him because he doesn't plan to use this all day, every day. This is going to be an occasional use tool for him as far as I understand. So I'll just let him know that I noted that and keep it in mind for the future. That if a crack does develop there, then maybe it can be welded back. I think this is an aluminum housing, if he's good at welding aluminum, or just replace the whole assembly, or the whole housing rather. The rest of this is pretty simple to put back together again. I just forget the best order of operations, so let's muddle through it. This way you can see everything. I think that just sets on there like that. And I have a new gasket that had to replace the old one on here. The old one just disintegrated. I think that goes like that, and then this can go in. The anvil can go in right now, but yeah, I guess I'll do the anvil next, and then the housing will slide on over the entire thing. That's what I'll do. I just gotta grease the anvil. And this is extremely heavy and awkward, so hopefully I don't drop it. No promises. I'm trying to do two things at once here. It's not easy to keep my brain focused. So I'm just greasing the dogs on the anvil while I try not to drop the whole assembly here and not get grease all over everything. Something's got to give, and it looks like it's the grease. Okay, nothing we can't clean up. Now it's extremely top heavy. But what you can see now is, as I turn this, it turns freely in one direction until the dog engages the hammer, depending on how that hammer is rotated on its pin. And that's what provides the hammering action. And I forgot, this whole assembly here turns within the housing, so this is all going to get a coat of grease too. And I have already put a drop of thread lock on these bolts. And now the same as last time, we do progressive and sequential tightening because of the gasket. That didn't do anything. This is usually the point in my videos where I say, let's take it out to the garage, hook it up to the compressor and test it. But I got a workshop upgrade. I put a pancake compressor in the shop, so now I have compressed air at the ready, which I am so glad I did. It's one of those things that just gives you a level of convenience that is just a sigh of relief. And it's great to have compressed air right here. I can blow off work surfaces, use it on little things that I normally wouldn't use it for, like cleaning up screw threads or just blowing out the shop, and I love doing it. So I put a regular quarter NTP industrial style connector on here just to test it. Ideally, it is not what you want to be running these things with. These need high flow, large diameter hoses and stuff. But just for testing purposes, to make sure that the mechanism works, this is going to be good enough. If you're ever thinking of servicing one of these yourself, it can be a little intimidating when you first look at them because they're large and they're not made like the regular 1/2 inch or 3/4 inch drive guns. But having gone through this, I'll say that it's easier to work on than the smaller ones. There are fewer parts to it, and although all the impacts that I've ever looked at make sense when you take them apart and see how the mechanisms work, this guy here is particularly easy to understand. The only thing I didn't get to dig into was the mechanisms in the handle, like the trigger and the control valve and the inlet. That might be another project for another time if I ever get the opportunity. Everything's held in here with little pins, so I think it's a matter of popping the pins out and then popping out the individual pieces and putting new ones back together again. It doesn't look terribly complicated either, because there's not that many things going on in this handle. just the throttle, inlet, and the control valve. So I don't think that having to work on those would be a big deal. Overall, I really enjoyed doing this because I got a chance to learn some new things, to see some mechanisms I haven't seen before, and honestly, I don't get 1-inch impacts in the shop very often. This is only the second one, I think, in 9 years, and the first one I had sent out to Power Tool Repair to have them do it, because it was just, I simply didn't have the time to dig into it myself, which I really wish I did now in hindsight. But glad I got a chance to do this. This is for my buddy and good customer, Sammy Salinas. I know he's watching the video, so this one's for you, buddy. Thank you for the business and putting your trust in my ability to work on this for you. Glad that we found everything we could find. It's in great shape internally. You should be able to use this beautifully for many years to come. Just keep an eye out for that crack in the housing. Now keep watching the channel because I've got loads of videos coming up. I've got a 3/4-inch Matco impact to work on, a 1/2-inch Chicago pneumatic impact, and a 1/2-inch Ingersoll 2235 Ti Max. So we have lots of air tool repair videos coming up. Check out the flyer drop video from this quarter if you haven't already. That posted a few weeks ago. And of course, we'll have more tools in the haul videos, and we're even going to do some live streams every month or so with friends of mine who can weigh in on the state of the tool and repair industry. So do me a favor and click down here now to subscribe so you don't miss any of it. Thank you so much for watching. And remember, use a tool. Don't be one.